Today we integrate materials, artificial intelligence and machine learning at many levels in our research work. Everything from low-level tasks where, for example, robots have learned by observing how to do certain things in the lab, maybe mix things or maybe move crucibles around. So that's what I call low-level artificial intelligence. But then also now there is, for example, so much computed data that comes from quantum mechanics. There are large databases like the Materials Project, and people have now been able to train large neural networks with which we can much more rapidly evaluate the properties of materials. These are so-called universal machine learning potentials, which essentially understand the physics and the chemistry of bonding, that they can give us answers very quickly. So they allow us to very rapidly screen new ideas for materials. I think it's very early to expect groundbreaking discoveries from AI because honestly, there are not that many groundbreaking discoveries in science in a given year. But we certainly see AI making interesting suggestions for new materials, new battery materials, for example, new thermoelectric materials, new hydrogen storage materials. I think that today we still have to see these ideas go through some other filters to make sure they are reasonable and they have the properties. But we've certainly seen the first indications that it can generate interesting new directions. So I think AI and machine learning will have broad impact on science. In principle, things like large language models that we see today, like GPT and ChatGPT, can incorporate almost any field of science. In my own work, obviously, we focus more on the development of new materials, materials for batteries, materials for chemical conversion. But I think you see a lot of impact of AI also in biology, in medicine, where it can come up with new ideas. So I think the impact will be very broad across science. So I think what AI and machine learning is going to do is really transform the way we do science. Historically, we have mostly done science in the same relatively slow way. We have ideas, we test them, we analyze the results, and we go back and refine our ideas. I think with AI, coupled with robotics and autonomous labs, we will be able to do that process much faster and much more comprehensively. So rather than having the knowledge of one human scientist, the AI can incorporate the knowledge of many fields of science, in some sense of many human scientists, and rapidly go through new iterations for materials, ask questions from an experiment in the lab, analyze the data coming from the lab, build a new hypothesis on that. I think within the next decade, we will see AI actually drive experimental research in the lab. I think this will be a very novel way by which we do research. Imagine a very large laboratory with all kinds of instruments, all kinds of ways of making materials, and now an AI will actually decide what to do, how to analyze it. I think this will be highly innovative.